3I/Atlas is not just another phenomenon. On October 17th, 2025, NASA quietly updated its technical summary for the object. The cometary features section was removed. In its place, observation ongoing, classification under review. It wasn't an announcement. It was a quiet retraction. The scientific community noticed immediately. Because when an agency like NASA pulls a label, especially one as basic as comet, something significant has changed, and not by a little. The review began after a chain of anomalies started coming in around October 10th. First, it was a trajectory drift. Then, the thermal inconsistencies. Then something more subtle, the disappearance of expected spectral signatures, as if the object were suppressing parts of itself. Initially, instrumentation error was the leading theory, but the data came from multiple observatories across different wavelengths, all pointing to the same conclusion. Atlas is not behaving like any known comet. The reclassification decision formed between October 14th and 16th. The orbital dynamics team raised the first concerns. Spectroscopy flagged the next red flag. Then came the internal review board for minor bodies. And finally, the label comet was stripped from its official record. What remains now is uncertainty. What was once a faint trace of ice and dust is now a compact, coma-less object, tailless, yet retaining thermal consistency well beyond predicted decay. And the most unsettling feature, a pattern of motion too stable to be chaotic, yet too weak to be actively driven. It's not dead. It's not breaking apart. It's just holding. 3I/Atlas no longer fits into any known category. It isn't a classic asteroid. It isn't a comet. And for now, it isn't explainable. The reclassification wasn't just technical. It was a tacit admission. What we're observing is not what we thought it was. And that shift from certainty to question is just beginning. Space doesn't make mistakes. It only follows laws. Orbital mechanics are among the most precise calculations in science, a field where millimeters matter and trajectories don't lie. And yet, 3I/Atlas is drifting, not wildly, not suddenly, but steadily, in ways no model can fully explain. It started on October 10th, when the Deep Space Network began noticing tiny deviations in the object's predicted path. At first, they were dismissed as observational scatter, but by the 12th, the residuals were growing. Not noise, not weather interference. Something more persistent. Multiple tracking systems confirmed it, from ESA's Near-Earth Object Program to JAXA's radar scans. The vector analysis showed a consistent offset in trajectory, small but real, and most critically non-gravitational. That changes everything. Standard orbital mechanics assume the only forces acting on an object are gravity, solar pressure, and, in the case of comets, sublimation jets. But Atlas shows no signs of outgassing. No coma, no jet plume, no source of thrust. Yet it's moving as if something were nudging it. Engineers compared the shift to known non-gravitational profiles. They checked against previous interstellar visitors. Oumuamua, Borisov. Both showed quirks. Neither looked like this. Oumuamua had unexplained acceleration but lacked visible mass ejection. Borisov behaved more like a traditional comet. Atlas somehow defies both molds. The motion is smooth, constant, slightly curved. It doesn't resemble a reaction to sunlight or heating. Instead, it follows a path that almost looks regulated. There's a pattern to it. Every 36 hours, the deviation vector resets slightly, suggesting correction. The object seems to adjust its path, but never drastically. No tumbling, no spin instability, just controlled drift, always returning to a mean course. Some theories propose delayed jet outbursts from volatile pockets under the surface, but no increase in brightness has been observed, no change in its spectral line, and no material has been ejected in any direction we can detect. It's not natural behavior, and that's what's raised red flags. Because in astrophysics, when something moves without an explainable force, we're left with two possibilities. Either the force is invisible or it's intentional. NASA hasn't gone that far, at least not publicly. But internal memos reviewed by independent analysts refer to the object's motion as anomalously constrained. That phrase, carefully chosen, avoids saying too much, while revealing what everyone's thinking. Atlas is not drifting. It's maneuvering. That possibility reframes everything. If this object is adjusting itself, whether autonomously or through some internal regulation, then we're not just watching a passive piece of rock from another star. We're watching something that responds, something that navigates. And as of this week, it's moving closer to Earth than any interstellar body ever has. The next course projection, released October 18th, shows a trajectory that flattens slightly as it nears the ecliptic plane, almost as if aligning with Earth's orbital path. We're not just tracking a visitor anymore. We're tracking something with a destination. Infrared doesn't lie. When visual observations fail, when shadows mask detail or the sun blinds our sensors, infrared reveals the truth. It shows where energy moves, how matter behaves, and whether an object is radiating or simply reflecting. That's why James Webb was pointed at 3I/Atlas. And what it saw wasn't normal. On October 13th, the Webb team captured a full-spectrum thermal scan of the object. The expectation was simple, passive radiation. A cold body warmed by the sun, radiating gently across its surface. But Atlas pulsed, not metaphorically, literally. The thermal map showed emission fluctuations that repeated every 6.7 hours, too short to be orbital, too clean to be noise, a rhythmic brightening and dimming across the object's midsection, as if a portion of its surface were activating, heating, then going dark. And it did it again, and again, and again. Initially, Webb's team checked for rotation. Maybe Atlas was spinning. That could explain thermal variance. But the fluctuation didn't track rotation. The warm region stayed fixed on the same relative longitude. The object turned, but the hot spot didn't orbit. It stayed anchored. That's not thermal inertia. That's behavior. Secondary scans looked deeper, mapping thermal gradients over time. The heat source wasn't diffusing. It rose sharply, plateaued, and shut off. Not decayed, shut off, like a switch. That's when things got complicated. Webb's long-range infrared lens picked up micropulses within the main hotspot, tiny oscillations just above the noise floor. Not random, not atmospheric distortion, repeating in intervals of 3.1 seconds. A resonance. Webb's spectrometry team flagged the signature, not because it was dangerous, but because it looked engineered. The phrase used in the internal report, non-thermal periodicity inconsistent with passive geological behavior. In plain terms, rocks don't blink like this. NASA didn't comment. They didn't deny the data. But the raw files were quietly moved behind restricted access. Only credentialed researchers with Tier 2 clearance can now access the full scan series, a shift that usually only happens when national security or planetary protection protocols are involved. Outside institutions, like the European Southern Observatory and Caltech's infrared group, have been working from the initial public dataset, and their findings echo the same concern. The thermal output of 3I/Atlas shows no known natural analog. It's not an outgassing event. It's not tidal friction. It's not residual heat from formation. It's too organized, too stable, too timed, and the pattern hasn't stopped. Follow-up scans from October 15th and 16th show the same intervals, the same plateau durations, the same emission zones. The object is still blinking methodically. Some have speculated exotic physics, quantum superheating, subsurface fission reactions, unknown ice chemistry. But none of those models explain the strict periodicity. None account for the fixed emission zones. And none predict what comes next. Because if this object is pulsing, if it's emitting energy in cycles, then the next question becomes, why? What purpose does it serve? If it's natural, then we discovered a process never before seen, something entirely new in planetary science. If it's not, then this isn't just a visitor. It's a message, encoded in heat, hidden from the naked eye, but revealed when we looked with the right kind of lens. The heat map doesn't lie. And now that we've seen it, we have to ask, what else is 3I/Atlas doing that we haven't looked for yet? When astronomers analyze an unknown object, they start with reflection. What the surface reflects and what it doesn't reveals what it's made of: rock, ice, metal, organic compounds. Everything leaves a signature. But with 3I/Atlas, the spectrum doesn't add up. Initial observations pegged it as a standard carbonaceous body, dark, with low albedo, consistent with comet nuclei or ancient asteroids. But deeper scans, particularly from a VLT in Chile and ALMA's radio arrays, have shown something strange. The surface isn't consistent. It's changing. Between October 10th and 17th, the object's reflectivity shifted subtly but measurably. Wavelengths in the near-infrared began to dip, while thermal emissivity stayed flat. That's not dust erosion. That's selective absorption. Materials shouldn't behave that way unless it's being altered. And the change wasn't random. It followed the object's orientation. The side facing the sun showed more variance. The dark side remained consistent, almost too consistent. Some suggested sublimation, ice boiling off, revealing different layers. But that's not what the data shows. There's no increase in mass loss, no tail, no coma, just a flat response. Too flat. Then came the radar echoes. On October 16th, NASA's Goldstone facility bounced high-frequency radar off the object. Expectation: rough surface, complex scatter, like most tumbling bodies. But the return was smooth. Too smooth. Like radar hitting a curved shell. The team recalibrated. Ran the pulse again. Same result. The return signature was so uniform it resembled metallic plating. No regolith. No natural pitting. Just a clean echo with almost no dispersion. This isn't how rocks behave. This is how engineered surfaces behave. Smooth curves that deflect signal, materials that absorb specific frequencies, outer shells designed to blend in with background noise. And it gets stranger. Spectroscopy teams trying to identify elemental composition found signal masking in multiple bands. Specific frequencies, including those used for common mineral detection, returned partial nulls. It was like something was scrambling the light. Again, theories emerged. Surface charging, magnetic distortion, rare alloys. But none explain the pattern. The mass bands aren't random. They correspond to key identification windows, the same wavelengths most telescopes rely on to classify celestial materials. It's as if the object knows how we look at it, and is actively hiding from that gaze. The term being whispered in private research calls is spectral cloaking, not a science fiction shield, but a deliberate, passive design to confuse analysis. A skin that looks natural from afar, but becomes unreadable up close. If true, this isn't just a rock from another system. It's a masked mechanism, camouflaged to mimic carbonaceous asteroids, but revealing patterns that suggest intent, not just to travel, but to remain misidentified, to pass as ordinary. And that raises the obvious question. Why? Why would a body arriving from deep space need to mask its surface? Why scramble its materials, suppress its reflection, and deflect radar? Unless it's not just passing through. Unless it's observing us. Or worse, preparing for something. Right now, scientists are divided. Some cling to exotic natural explanations, amorphous carbon transitions, unknown interstellar coatings. But the evidence isn't trending that way. The closer we look, the less natural it appears. And as we approach its closest pass, just 11 days from now, we may not be watching a comet or an asteroid at all. We may be watching a probe. One built not just to travel, but to hide. On October 15th, something strange happened over South America. A series of shortwave radio observatories, including those in Brazil, Chile, and Argentina, recorded bursts of interference. Sharp, narrowband disruptions. Not broadband static. Not solar activity. Just 3 bursts, each lasting less than half a second. Spaced exactly 19 minutes apart. At first, they were written off. Equipment fault. Local noise. Until the timestamps were cross-referenced with 3I/Atlas's position. Each burst occurred when the object crossed a specific azimuth relative to Earth's surface. The same angle, 3 times, from different observation points. The signal was directional. aligned with Atlas. It didn't repeat on the next orbit. It didn't show up in satellite feeds. It didn't match any known Earth-based transmission. And crucially, it wasn't picked up globally, only from ground arrays with direct line of sight. That's what makes it so concerning. The signal was localized, focused, and short. Teams at Arecibo's successor facility, along with Lofer in Europe, combed through deep field data from the same window. They didn't detect the burst itself, but they found something stranger, a null zone. During the same time frame, cosmic background noise dropped sharply for several milliseconds. A blackout, as if something momentarily canceled out natural radio sources. That doesn't happen. Space doesn't pause, except it did. And only when Atlas was aligned with the instruments. What causes that kind of drop? The leading theory isn't comforting. It's intentional jamming. Not from Earth, but from Atlas. Not noise, but silence. Engineered. The idea of signal suppression from an interstellar object wasn't even on the table 2 weeks ago. Now, it's being modeled in lab simulations. And the early results suggest a rotating emitter, something that sweeps space with targeted pulses, quieting areas it scans. NASA hasn't responded. Neither has the International Telecommunications Union. The events haven't been publicly acknowledged, but the raw logs are clear. Something out there disrupted Earth's sky, deliberately, briefly, and in perfect sync with a known object. And now, as Atlas approaches its closest pass, the world is watching not just with telescopes, but with radio ears, listening, and wondering what else might go quiet next. For weeks, the world has watched 3I/Atlas, an object once labeled a comet, then reclassified, then flagged for behavior that defies every natural model we know. But a darker question has started to circulate in private meetings, behind encrypted calls and within classified memos. What if 3I/Atlas isn't just cloaked? What if it's a decoy? The idea seems extreme until you line up the data. The trajectory is precise. The surface masking is deliberate. The energy emissions are timed. The radio interference is surgical. It's not just trying to blend in. It's demanding attention. And it's getting it. Every major observatory on Earth is tracking it. Every infrared array, every radar dish, every orbital telescope is pointed toward this single object, which raises the obvious strategic question. What are we looking at? Because in the last 2 weeks, multiple satellite systems have reported dropouts, not in the direction of Atlas, but adjacent, peripheral blind zones, narrow gaps where no data was recorded, not because the systems failed, but because nothing registered. That's not nothing. That's absorption. If Atlas is acting as a decoy, if it's intentionally emitting heat, scrambling light, and interfere with radio to pull our sensors, then something else could be riding behind it, close enough to share the vector, far enough to hide in its wake. A second object, or a structure, or a system. A true cloaked body wouldn't emit, wouldn't blink, wouldn't jam. It would drift, quietly, unseen, and we wouldn't notice. Because Atlas is too loud to ignore. It's a tactic as old as warfare. Distract the watchtower while the real movement happens in the shadow. And in space, with millions of kilometers of margin, shadow is easy to manufacture. We still don't know what Atlas is. But we do know this. It's not passive. It's not random. And it might not be alone. The last 48 hours have triggered contingency briefings across at least 3 agencies. Not for impact, but for proximity. If there's something trailing Atlas, it could already be closer than we realize. And by the time we confirm it, our instruments may already be looking the wrong way. When something extraordinary happens in the sky, NASA talks. They host press briefings, push out data, publish preprints, especially with objects like 3I/Atlas, rare, mysterious, and now generating global interest. But not this time. Since October 14th, NASA's public channels have gone dark on Atlas. No updates, no press releases, no interviews, just silence. And that silence is speaking volumes. Inside sources say activity behind the scenes has spiked. Tasking orders for infrared and radio telescopes have increased threefold. Time normally allocated months in advance has been redirected toward Atlas. That kind of reallocation doesn't happen casually. Data servers tied to the Jet Propulsion Laboratory now show lock segments labeled DART-D, a code not seen since the last planetary defense exercise. Internal tracking wikis have been restricted. IP logs suggest rapid collaboration across Langley, Ames, and Goddard, and yet no one's talking. Reporters pressing for comment received the same response. No public statement at this time. But absence is a statement. Historically, when NASA's confident object poses no threat, they say so early and often. They use clear language, no impact risk, routine flyby, fully characterized. We've heard none of those phrases. Instead, we get qualifiers, preliminary, pending update, under analysis. And now we're hearing nothing. It's not just NASA. The European Space Agency's NEO Coordination Center removed its public Atlas tracker on October 16th. The Minor Planet Center's latest ephemeris hasn't updated in 36 hours, a delay that almost never happens. The agencies aren't confused. They're cautious, and that's what worries people. Because when space agencies stop talking, it usually means two things. Either they're preparing for control messaging, or they've seen something they can't yet explain. And with Atlas, can't explain seems more likely by the day. The object is still en route, still on track for a close approach. But the ones who know it best, the people whose job is to monitor threats, have gone quiet. Maybe it's caution. Maybe it's coordination. Maybe it's both. But in a world where silence can spread faster than panic, the lack of clarity creates its own kind of signal. And right now, that signal says, something's coming. For now, all we can do is wait. But be warned, because this is sure to be the talk of the town. Subscribe to see more news about 3i Atlas and the universe.